continuing with the previous example of extending the tick-tock. So far, we have seen that we introduced modeling processing delay to our system, such that when either tick or tock sends out the message, it introduces a processing delay of 1 second. In this particular module, we are going to introduce the usage of random numbers and parameters. Specifically, what we are interested in is, we are going to look at the usage of random numbers in randomly losing packets, and we are going to change the delay from 1 second to a random value. For this, these are the files tx7.cc, ticktock7, or omnet.ini. It is relevant to mention here that we are going to define the working of these random numbers in the CC file, and we are going to pass the arguments and the values to these arguments in omnet.ini or NED file. When we look at txc7.cc file, here in the upper part of the code, that's the usual part, that whenever a node receives a message, it is about to transmit a message and it says wait time is over, sending back message. Here, what we introduce is, we introduce in the lower part of the code the concept of losing the packets. This is one of the practical moves to a realistic network where on a communication channel, packets are often lost. Here you can see that it is uniform distribution. Uniform distribution is actually a distribution that randomly takes any value between 0 and 1 in a uniform way. So the likelihood of every outcome is the same. Here, if the loss probability is declared as 10%, it means that whenever the uniform distribution turns out to be less than 0.1, it actually means that the messages would be lost. When the messages are lost, we are going to display the message losing the message, and we are going to call the delete message function. Continuing, here we are introducing latency in the way where we wanted it to be random. Here, as you can see, that the simulation time, which was fixed to the processing delay of 1 second, is now taking the value from the delay time. And in the lower part of the code, the display is such that message arrives, starting to wait, and the delay shown in seconds. And the event of sending back the packet is triggered at schedule at simulation time, whatever the time may be, plus the delay, and the event is executed. Now, the delay parameter is coming from .ned file or the .ini file. Here, we use .ned file. ticktock7.ned shows how we give the randomness by using the exponential distribution. As you would study, uniform and exponential distributions are well-known distributions. Here, when we are using exponential distribution, we need it because it is a memory-less distribution, most suitable to such scenarios. So, we give the argument of 3 seconds. It actually means that the mean is given as 3 seconds, and the exponential distribution is going to give out a random number, anything between 1 second to 3 seconds.